record. Okay, so let me share Atom. So remember this, we have discussed this in class last time. This is the square root module. We're going to use this in our module, okay? So bring the computer closer to me, okay? And yeah, so I will create another folder to organize my work. So let's call it hypotenuse calculator, okay? Calc, right? .v. Okay, this is the folder name, okay? And I am going to copy the square root module. Right click, copy, and where is the hypotenuse? Paste. Okay, and then a new file here. Let's call it calc.v, right? So close this and open up our square root. Right. Let us assume that our numbers are signed. Okay, our numbers are signed. So I'm going to change dn to signed. Okay, it is signed input, and this one, the output is also signed. All right. Of course, the output is a square root, so it is supposed to be positive, but you know, it's that's fine. We just I mean, the sign bit here is always going to be a positive number. All right. So this is for the square root module. Okay, let me just check that everything is so I have signed here as well, and also signed here. Yeah. All right. I think I don't need these functions actually. They're just distracting us without any point. Okay. Let's just make our module shorter. Okay. So this is the square root calculator. Right. We need the hypotenuse. So I'm going to copy this and all of this, because actually we are going to instantiate the square root module in our circuit. So our module name is called the hip calc, okay? And it is actually taking the parameters here, okay, for the fixed point arithmetic. And also it is taking the clock, reset, go, and dn, and d out, and ready, right? Right. And for these, actually, I'm going to use same things here, okay? Type. Yeah. But we have to have signals for the square root. Square root itself, think high quality. Is it like this, or let's see the? Yeah, it is. It is actually like this. Okay. So we are going to pass actually width and scale as is, okay? As is passed from the parent module, okay? And then we need to set these parameters. So I'm going to use the binding here. The clock is the clock, and reset is reset. And dot go is what? What did we call it? Square root go, yeah? We need to create the signal. dn is square root dn. And d out is square root d out, yeah? And ready is square root ready. Square root ready. Okay? Can put it like this so that it becomes more readable. Yeah? All right. Right. So we need to declare a bunch of registers. So register square root go and what? We need the register signed, and it is actually width. So this is square root dn, yeah, and these two signals here actually are wires, yeah, wires, because they are the outputs, yeah, they are the outputs. Register wire. I'm sorry, wire. I put ready and wire. Square root beyond. Yeah. Okay. I believe I should say signed here, right? Yeah, signed. All right. So I just repeated that. There is no need for this. Okay. Right. You guys have any questions so far? Any question? Did I lose you? Right. I have an always block here. Let me see the. Did you try to speak, Shabab? And because sometimes my speaker does not work. If you
No.
okay, okay. Right. Always at what? Always at the positive edge of the clock. Okay, and then begin and end modules, right? So the first statement is to check for the reset. If reset, then what do we do? My state is going to be S0, yeah? S0. So let me just copy the local parameters as well here. I don't know how many states. I need to check the diagram, the state chart, in order to know how many states I need, okay? Let me just check that quickly. You remember, Shabab, how many states I need? Six states, yeah, 6 states. I need 6 states. So yeah, I can just live with 5. Okay, let's keep a 6 just in case. Okay, just in case. Actually, I have more than it's 8 states here, right? 8. So this is 4, 5, 6, 7, 8. Yeah. So my state variable state, which is a register, which is how many bits? 3 to 0, 4 bit, and its state. Yeah. This is the present state. Yeah. So in case I push the reset button, I go to S0. Okay. Else, what do I do? I check the state. Yeah. I check the state, and then in case. Okay. If the state is S0, what do I do? At the state, just check the diagram. Check the diagram. First of all, I have a begin and end, because there is actually multiple assignments here. Begin, multiple instructions or register transfers. Begin and end. Okay. The first one is ready is 0. Okay. And the second one is F. You can say F. Go. I'm just variating the F go, then where do you go? State is what? State is S1. Otherwise, please, when you look at this video, okay, make sure that you have a snapshot of the ASM chart to check whether I'm doing this right or not. Okay, so else state is S2. Yeah, S2. S1, in S1, my state is going to be, depending on go, if go is 1, then I'm going to stay in S1. Otherwise, I'm going to go to S2. In S2, my state, again, is also depends on go. Yeah, depends on go. And S2, this is S2. But actually, I have to say an F statement. Why? Why do I need an F statement here? If go, if not go first, then state. Actually, I don't need this. If go, then begin and end. Yeah. Begin. I have my A to be equal to dn, and my state to be S3. Okay. Otherwise, do not change A and do not change the state. Yeah. So we need to define A and B. Yeah. It's the same type as Bn, except that you know registers. This is B, and this is actually I don't need 2 lines, A and B, like this. Yeah. Yeah. And so in S3, what do I do? I'm just looking at the ASM chart, Shabab, and just writing that directly. So in S3, it is going to, the state is going to be a function of go. If go is 1, then I stay in S3. Otherwise, I go to S4. Okay? And in S4, I have to have an F statement here because there are multiple statements, multiple assignments. Okay? If go, then what do I do? Begin and end. And between begin and end, I have B gets dn, and go is 0, and state is S5. All right, Shabab? So far, so good? S5. I have some mealy, some more outputs, actually. Yeah, I can say square root go is 1, begin and end, of course. And square root dn is A multiplied by A plus B multiplied by B. And I want to find out the square root of this, right? And what do I do now? If what? Square root
ready.
Ready, excellent. Yeah. If square root ready, then
S
theta out.
D equals SQ out.
Excellent. Square root data out. And of course, begin. And state is actually, yeah, state depends on go. Yeah, depends on go. If go is 1, then I go to S1. Otherwise, I go to S2. And then end here and end at the end. Yeah. So this is end F and this is end begin. Yeah, at the beginning. Okay, I hate writing things in one line, but that's one way of doing it. Of course, I expect you to be more aesthetic when you write your code and more stylistic. So please do not follow my example, okay? All right, S6, now there is no S6, right? So I say here, default. The default is just equivalent to pushing reset. We go to S0, okay? Why do I need the default state here? Why do I need the default, Shabab? Any guess why do I need the default? Because we are not using the entire state range, yeah? State is 4-bit here, okay? State is 4-bit. However, we are not using the full range of state. If you use the full range of states, then you don't need the default, okay? You don't need a default. طيب, we finished this now. I need to create a test bench and then call it a night. The TB hit.b, right? And then I'm going to copy yeah, probably. Yeah, copy the entire thing and then what is that? Change it accordingly. So TB, call it hip, yeah? I called it hip, okay? And then I have 3 signals, registers here, and one DN and one D out. My module is not the square root, actually, it is the hip calculator, calc, yeah? They call it hip calc 0, yeah? And I'm connecting actually the same signals here, I believe, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, exactly. And we have an always for the clock, and then initial begin. Let me name the waveform hypotenuse calculator waveform, and then this is dB hip. Okay. Then we have a reset here, and okay, positive edge of the clock. This is the reset now, and then I set reset to 0, and in the next negative edge I set go to 1. Okay, once you set reset to 0 here, okay, reset is not active. So in this edge, go is 0. So we will go to which state now after this? we go to
State 2
say it again.
in the state 2.
Yeah, do we go to S1 or S2? Which one?
S2.
S2, because go is 0, yeah? Because we need only one state, one clock cycle to detect the positive edge on go. Okay, and so we have go V1 here, and then wait for a positive edge on ready, and then just finish, okay? Just finish. But we didn't actually, so let's give another positive. So we gave A, but we didn't give B. So let's give, for example, a good example here could be what? 4, 3, yeah, 9 plus which two legs give you an integer hypotenuse يا شباب. You guys probably remember that better than me. So if we get for example 3 and 4 or 1 and 2, 1 plus 4 is 5. No, 4 or yeah, 4 to 16 now plus no, we need 10. 9 plus anyway, we can say here 2. We can convert it to the calculator. We can calculate it in the. We can punch it in the calculator and then compare the result. So the first leg is 3 here. A. This is A, and we don't wait for actually ready here. Okay, we need to change go here to 0, okay, and then give go to 1, okay, and then also at the same time take the n to be the other leg, which is, let's say, 2, okay. So the hypotenuse length will be 4 plus 9, which is 13, the square root of 13, yeah. But we need to scale this by the scale, yeah, in order to make it exactly 2, right? And then we wait for a positive edge on ready, and then we finish after 10 what? 10 nanoseconds, yeah? 10 nanoseconds means that this is 1 clock period, yeah? Let's wait for 2 clock periods and then finish, yeah? Right. Let me switch to the terminal and try to compile. Share the terminal. So Verilog, we have the HIP calculator, and we have also to compile as well the square root calculator, okay, because we're using that. Also the TB hypotenuse, okay, hypotenuse. Hopefully things will go smooth. Okay, we have an error here in the hypotenuse calculator. Okay, line number 6. Let's go to line number 6 in the HIP calc and see what is wrong here. Okay, we didn't put a semicolon. Okay. So I just went to the code, okay, which is HIP calculator.v, and then found that I missed a semicolon. I put it, and then I'm compiling again now. Again, I have, let me just share the desktop. It's much easier this way, so that you guys can see everything. I have another error now in square root.v in line 21. Let's see, because we changed it actually. 21 signed. Okay, not signed. Okay. Let's. Okay. Error unknown module type. Okay, this is in TB. Okay, the module name is not correct. HipCalc. Let's see. Hip P. Okay, I missed the P here. Okay, now it is running. Inshallah, it will work now. Oh man, it's taking forever. There is something wrong here. Okay, finish. Let's now when this happens, you go back to the code, to the test bench. Okay, and instead of square root, instead of waiting for ready, just comment this out and do 1000 or 100 or 500 time units and then finish. Okay, to see what's going on. Because this statement here is the one that is holding it forever. Ready is never one in this case. And then we check the wave and see what's wrong. Okay, so now we have our GCD or VCD file. Okay, let me drag it and drop it here. And so we have the clock. And oh, the clock is okay. No, it is correctly set up. Reset and ready. There you go. And DM. Right. Ready and be out. Oh, okay. There seems to be something wrong here in the out because it is assigned to something. It is actually assigned to something. Let's see what is that thing, you know, that to so I want it to be in fixed point, have 12 bits and turn it on. Decimal. Okay, yeah, it's 2 and 3. Same thing here. We have to specify fixed point 12 and turn it on. And we want it in decimal. Okay. Oh, okay. That's definitely not correct, right? I mean, 230 is definitely not correct. 230 point something. So in order to check that, we need to dig deeper in the hypotenuse calculator. Let's see the square root itself. So the square root, we want to see whether ready go to 1. Ever goes to 1. Okay, it goes to 1 actually. And let's also check the out. The out. On. One. And that is definitely not correct. Something is wrong here. Okay. Anyway, I'm going to fix that. I'm going to fix this and debug it. I'm not going to take much longer time than tonight. Okay, than tonight's time. And I will let you know on Teams. Okay, what was wrong. And also, we'll post the correct code, okay? I'll post the correct code. Let me stop recording so that the recording doesn't become so long, okay?